When you first log into a Linux server, you are met with an alphabet soup of cryptic folders like /etc, /var, and /usr. To a beginner used to Windows, these names offer no immediate clue as to what they contain or why they exist. Windows separates storage into independent drives like C or the. Linux, however, pulls every physical disk and partition into a single, unified starting point. This starting point is the root directory, represented by a /, where every piece of data branches out. This works because Linux treats everything, whether a text document, a software application, or physical hardware, as a file, using the exact same standardized file blocks. Navigating these specific paths becomes a matter of logic rather than guesswork, once you understand the map that remains consistent across nearly every Linux distribution. We can divide the system into layers, starting with the static areas that rarely change. First is /home. This is the residential zone, where individual users store their personal documents, scripts, and downloads. For the tools needed to actually run the system, we look to /bin and /sbin. These directories house the essential commands for basic operations, such as moving files or managing the network. Then there is /usr. While it sounds like it's for users, it actually functions as a software mall. It contains the vast majority of the applications and support files installed on the machine. For third-party enterprise software that doesn't come with the standard system, Linux provides /opt. This acts as a dedicated commercial zone for optional, self-contained applications. This organization keeps the core architecture of the system separate from the volatile data created by the people using it. To understand the data that does change, we look at the control room, /etc. This directory contains the configuration files that determine exactly how your programs and services behave. This diagram compares static control room files to /var. Configuration files remain a constant size, but var holds data that grows over time, like logs. Physically separating them prevents expanding logs from consuming the space needed for core files, which would crash the system. Short-term data lives in /tmp. This is an ephemeral workspace where applications can store data for a few minutes. The system is designed to wipe this directory clean every time the machine reboots. Dividing state configurations from variable data ensures that even if a log file grows out of control, the rules governing the system remain safe and accessible. The most advanced layer of Linux is how it represents physical hardware and live system memory as a stream of digital text. In the /dev directory, you will find files that represent your hard disks, keyboards, and terminals. To talk to a piece of hardware, the system simply writes data to one of these files. Then there is /proc. If you were to look for this directory on your physical hard drive, you wouldn't find it. It does not exist as a collection of magnetic bits on a disk. This diagram shows how /proc functions. It is a real-time illusion generated by the system's kernel. It presents live data, such as CPU usage and memory stats, as if they were text files you could read. By turning hardware and memory into files, Linux allows administrators to monitor and control the entire physical machine using the same tools they use to edit a simple document. The directories that once looked like a random collection of letters now reveal a specific, organized purpose. Once you recognize these core categories, you can find what you need on almost any Linux server in the world. This flowchart shows the practical result. When an application fails, you locate the program in /usr, check the rules in /etc, and look for the specific error in /var/log. Let's see if you can apply this logic. If you needed to find the file where the operating system stores user account credentials, which directory would you check? Here's a hint. Credentials are the rules for who can access the machine, so they belong in the control room. Put your guess in the comments, and I'll see you in the next one.
Don't forget to subscribe and press the bell icon.